In this podcast, we're going to go over the two kinds of symmetry and how to identify them. The first kind of symmetry is called line symmetry, or it can also be called reflection symmetry. A shape has line symmetry or reflection symmetry if it can be divided in half with a line so that both halves are mirror images of each other. This heart has one line of symmetry. In order to identify line symmetry or reflection symmetry, we just state how many lines of symmetry there are. In this second example, in this sun, there are more than one line of symmetry. There's a line of symmetry that goes through each point, each ray of the sun, and there is also a line of symmetry that goes between each ray in this sun. So to identify this line symmetry, we just need to count the lines of symmetry. Now be careful. A lot of students will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and say that there are 16 lines of symmetry. But there's not 16 lines of symmetry. When I count 1, 2, 3, 4, 5, 6, 7, 8, there's only 8 lines of symmetry. So line symmetry is identified by how many lines of symmetry there are. The second type of symmetry is called rotational symmetry. Rotational symmetry is when you take an object, a figure, and you rotate it around its center and it lines back up with itself. So in this first example, this figure has a center right here, and to figure out the rotational symmetry, if I look at this piece right here, I'm going to have to rotate this piece right here all the way to here in order for the object to line back up with itself. If I rotate this image, I have to rotate it this far before it lines back up with itself. Now if I look, this angle is 120 degrees big. So this object has rotational symmetry at 120 degrees. I can also take this object and rotate it 120 plus another 120 to line back up with itself, which means that this object also has (240 degree rotational symmetry, and I can rotate this object all the way back to the beginning for 360 degree rotational symmetry. So rotational symmetry is identified by angles. Notice that I can rotate this object 3 times. 360 degrees divided by 3 is 120 degrees. So this object has rotational symmetry every 120 degrees. In the second example, the words spell out rotational symmetry. And if you turn your paper upside down, the words still spell rotational symmetry. When you take a word and you can rotate it back around and it still spells the same thing, this is called an ambigram. So if I look at this object, the center of this object is right here, and I would have to rotate this object this far for it to line back up with itself. The amount of degrees, 180. I can also rotate 360 degrees to line back up with itself. So this object has rotational symmetry every 180 degrees. Some objects can have both rotational and line symmetry. These two objects only have rotational symmetry. There is no line that reflects mirror images in either one of these figures. Now if I look at the first example, the only rotational symmetry I have is 360 degrees. So in this object I would say that there are no rotational symmetry. So this object does not have rotational symmetry. But this object has line symmetry and rotational symmetry. If I look, the center of this object is right here. If I draw a line through this point, I'm going to have to rotate to this point for it to line back up. And I can also rotate to here, and here, and here, all the way around the sun. So really, I'm going to take 360 degrees and divide it into 8 sections. When I do that, I get 45 degrees. So I have rotational symmetry every 45 degrees. At 45 degrees, and 90 degrees, and 130, and 180, all the way up to 360. So the two types of symmetry are line symmetry and rotational symmetry. Line symmetry is identified by how many lines of symmetry we have. Rotational symmetry is identified by degrees. Some objects have only line symmetry, some objects have only rotational symmetry, and some objects have both line symmetry and rotational symmetry.